In this video, we will talk about how to determine if a table of x and y values represents direct variation or inverse variation. So here are the two formulas. If x and y have direct variation, we can write the formula y is equal to k times x, where k is known as the constant of variation. Now, one thing we'll notice is that we can solve for k if we just divide both sides by x. So we could write k is equal to y divided by x. Now, we say that x and y have inverse variation if we can write this formula, y is equal to k divided by x. And we'll notice that if we multiply both sides by x, we can solve for k. So we could write k is equal to x times y. So if we have this table of x and y values over here, and we want to know if it represents direct variation or inverse variation, we just have to figure out which one of these formulas for k is true. So for example, let's check this first formula, y divided by x. For this one, we would have y divided by x. 12 divided by 1 is 12. 3 divided by 4 is 3/4. And 2 divided by 6 is 2/6, or 1/3. Now we'll notice that these are not all the same value. So that means x and y do not have direct variation. So next, let's try the inverse variation. So let's use this formula, x times y. So that would be 1 times 12 is 12. 4 times 3 is also 12, and 6 times 2 is also 12. So notice we do get the same value each time right here. So that means that x and y do have inverse variation. So we'll write inverse as our solution on this one. And this 12 that we found, this is known as the constant of variation. So if we wanted to write the formula that explains x and y right here, we could write y is equal to 12 divided by x. And we'll find that if we plug in each x value in this table right here, we'll get the correct y value. So 12 divided by 1 is 12. 12 divided by 4 is 3. And 12 divided by an x value of 6 is indeed 2. So this is the formula that describes the inverse variation between x and y. All right, let's try another example. Let's say we have this table of x and y values, and we want to know if it represents direct variation or inverse variation. So again, let's first try to see if this equation is true for direct variation. So we'll say y divided by x. So here we would get 12 divided by 4, that's 3. 24 divided by 8, that's also 3. And 36 divided by 12, that's also 3. So because each of these are the same value, that means we have direct variation. And this 3 is our constant of variation. So we'll say direct variation for this one. And the equation that we can write is plug in a 3 for this k right here. So that would be y is equal to 3x. And we'll notice that if we plug in the x values from the table, we should get the corresponding y value. So if we plug in a 4 for x, we get 3 times 4, which is 12, which is what we get here. And if we plug in an 8 for x, 8 times 3 is 24. And if we plug in a 12 for x, we get 12 times 3 is 36. So this one represents direct variation. All right, let's try one last example. Let's say we have this table of x, y values. First, let's check if they have direct variation. So we'll use this formula right here. So y divided by x. So 4 divided by 2, that's 2. 15 divided by 5, that's 3. 5 divided by 10, that can be simplified to 1/2. So we can see the value is not the same each time. So this must not be direct variation. So now let's try inverse variation. So we'll try this formula, x times y. So 2 times 4 is 8. 5 times 15 is 75. And 10 times 5 is 50. So again, we're not getting the same answer each time for this one either. So this must not be inverse variation. So in this example, we would say neither. It doesn't represent direct variation or inverse variation.